We have studied various types of converters, DC to DC converters, AC to AC converters, AC to DC, DC to AC. Hard switching is easily to understand and therefore it is used almost universally in power converters outside of the low power DC to DC space. Hard switching is thought to be a lower cost because only a limited number of components are required to drive the transistor between states. Hard switching is cost is very low because less number of components are needed to drive the transistor from on state to off state, off state to on state. The drawback of hard switching is if you reduce transistor switching frequency, you have to reduce the transistor switching frequency to obtain the efficiency. If you take example, frequency is equal to 1 by T. 1 by T. If you reduce the switching frequency, the time will be increased. Time will be increased. So what will happen means the number of times the switch on and off is reduced. So automatically what will happen means the switching loss is less, so efficiency is increased. But what happen is when you are reducing the switching frequency, it will produce high harmonics, distortion and output ripples. The distortions and ripples generally needed to be filtered. You have to filter this distortion and ripples. For that we need the filter. So we need a filter, you have to design a filter. So when you add a filter to the circuit, the cost, the size and weight of the circuit will be it increases. In short, with the hard switching, the switching loss generated by switching faster means less conduction loss can be accommodated. So there are two loss, one is called as switching loss, another one is conduction loss. So if you reduce the switching frequency, the switching loss is reduced. If you increase the switching frequency, the switching loss is increased. So the drawbacks of this hard switching is efficiency is less, cost is high, size is high, weight also high. Next we can see about soft switching. The soft switching was introduced in 1980 by Deepak Raj Devan. So the main aim of this soft switching is to prevent the overlap of the voltage and current waveforms during transistor commutation by using external circuit. You all know what is meant by commutation means. Commutation means turn on and turn off. If you want to turn on and turn off any switch, we need some external circuit. By this external circuit, we are going to turn on and turn off, and also you have to prevent the overlap between voltage and current. So there are two types of methods are there. One is called as soft switching, another one is soft switching. There are two types. One is self-resonant, another one is called as force resonant. In power electronics, we have studied about various types of commutation technique, class A to class F. So class F is called as natural commutation. Class A to class D is called as force commutation. So in class A, class B, class C, class D and class E is called as force commutation. In force commutation, there are two types here, self-resonant and force resonant. First, we can see about self-resonant. In self-resonant soft switching, a self-oscillating circuit is used for the transistor commutation, resulting in the offset of current and voltage waveforms. The benefit of self-resonant soft switching topology are eliminating the switching loss, increase the efficiency, and reduce the electromagnetic interference. Self-resonant means there is in the load overlap means we are using the inductor and capacitor. So naturally what will happen means this, by using this LC circuit, it will get turn off and turn on. By using the self-resonant, we can increase the efficiency, reduce the electromagnetic interference, and we can reduce the switching loss. The main drawback is it is not used for non-isolated power converters. What is meant by non-isolated means if there is power converters. Power converters, there are 4 types: AC to DC, DC to AC, AC to AC, DC to DC. In DC to DC converters only, there is no transformer is used. So if there is no transformer is used means that is called as non-isolated power converters. For this, we can use this self-resonant soft switching methods. We cannot use for other 3 types. The force resonance soft switching topologies we can use for all the power converters: DC to DC, AC to AC, AC to DC, DC to AC. This also, it will eliminate the switching losses, it will increase the efficiency, and it will reduce the electromagnetic interference. Here, the force resonance soft switching topology needs some numerous input. Why we need this input is, it is used to calculate the time required to force the current and voltage to 0. For that, we need the what is the input voltage, what is the load current, what is the transistor voltage, and what is the transistor current. Based on these parameters, you can reduce the force the current to 0 and force the voltage to 0, and we can turn on and turn off the switches. If you use this method, the switching loss is reduced. So switching loss is reduced, we can increase the efficiency of the power converters. This is all about the difference between hard switching and soft switching. Next class, we can see the different topics on the 5th unit. Thank you.